Good morning all. So this is the third lecture of this course, and in the last lecture I discussed how to convert a decimal number into any other base, and I told you that if you have to convert the integer part of this number into any other base, what you do this by this successive division. And for the fractional part, in order to convert a decimal number into any other base, you do by successive multiplication by the base of the number. Let's take one more example for this fractional part. I have done this fractional part, base 10 into base 2 multiplied by 2, base 10 into base 8. Let's take one more problem. That suppose I say there is a problem, it says suppose 0.96. Suppose I say, this is an example here, let's take an example, 0.96, this is in base 10, and suppose I say what is the corresponding number in base 16. That is, it is simply decimal to hexadecimal conversion. So decimal part is to be converted. I told you in the last lecture also, what you do, it is simply 0.96. I multiply this by 16. I multiply this by 16, so this will be 96 and it will be 15.36. Now what I do, I simply write this 15 here. This is what I told in the last lecture. I write this 15 here, integer part, and this fractional part here, this 0.36. Further I multiply this by 16. So 0.36 into 16, this results in 5.76. I write this integer part 5 here. I am writing this integer part 5 here, and this fractional part 0.76 I write here, 0.6. Further I multiply this by 16. If I multiply this 0.76 by 16, this is 12.16. I have done the calculations just to save the time. Again I write this 12 here, this 12 here, and 0.16 on this side, 0.16. Then 0.16 multiplied by 16. 16 into 16 is 256, so it is 2.56, and I write this 2 here. And now I have to write this in the forward order only, in the normal order only. But remember that since I am converting this into base 16, if you remember this, in that A corresponds to 10, B corresponds to, if you remember, in I have told you in hexadecimal numbers 0 to 9 have their usual meanings in decimal, and you have A which corresponds to 10, then B is 11, C is 12, D is 13, E is 14, and F is 15, equivalent decimal of this. So here you have this 15 means F, and 12 means C here. So what I do, I replace this 15 by F. This is F. This is of course 5 as it is, 12 corresponds to C, and this 2 is as it is. And now I represent this in simple this order. And so the final result is, I can say that the 0.96, this number in base 10, this is equal to, in base 10 this number is equal to 0.F5C2 in base 16. I hope that this problem is clear to you. So in order to convert the integer part, you go by successive division, and in order to convert the fractional part, you go by the successive multiplication by this particular base where it is asked. Let's take one problem, a last problem, where you'll have integer as well as the fractional part, suppose. And suppose I say that, let's take an example, another example, last problem I'll take. It's an example here. Well, let me do it here. Let's take an example here. Suppose I say that convert 643.52 base 10 into, say, take arbitrary base. Suppose I say convert this into base 7. This portion will also be covered. Base 7. Now this is the integer part and this is the fractional part. So first I take the integer part. What I do, I convert the 643. I have to convert the 643 into base 7. Integer part is to be converted into base 7, means I'll divide this by 7. Continuous division by 7. So I divide this particular number by 7. So this is 7 9 is 63, 7 1 is 7 and remainder is 6. Now this 91 is less than 7. I divide this again. 7 1 is 7 and 2. 7 3 is 21. Remainder is 0. Further, I divide this by 7. 7 1 is 7. Remainder is 6. Now this 1 is less than 7. So I stop it here and I write this in the reverse order. I write this in reverse order. So what I have obtained from here, that the 643, only 643 in base 10, this is equal to 1606. This is 1606. This much in base 7. I hope this is clear. Now let's come to the fractional part. This fractional part is 0.52. Next part is this 0.52. This is the fractional part. Fractional part have to be multiplied by this base only. So 0.52 multiplied by 7. I'll multiply this 0.52 by 7. This is 3.64. 3.64. Again I write this 3 here. I'm writing this 3 here and this 0.64 here. 0.64 here. I multiply this by 7 again. I multiply this by 7. So it will be 4.48. 4.48. This multiplied by this. I write the integer part here. That is 4 and 0.48 here. Further I multiply this by 7. You can go up to 3 or 4 places after the decimal. By 7. So 0.48 multiplied by 7. This results in 3.36. Again I write this 3 here and this 0.36 here. I multiply this by 7 again. Last term I am taking. So it will be 2.52. 2.52. And what I do, I write this 2 here. Up to this point. You can proceed further also, but that is sufficient. And now I simply write this in the forward order. So I can say this 0.52. Finally I can say that this 0.52, this implies that this 0.52, that is the fractional part, 0.52 in base 10 is equal to 0.3432. 3432 in base 7. So overall 643 corresponds to this and 0.52 corresponds to this. So final result I can say, my final result is, that is, this is 643. 643.52 in base 10 is equal to 1606. 1606.3432. 3432 in base 7, and this is my final answer. I say this is my final answer. So overall, if I summarize this conversion, what I have done till now is that if you have a number n1, if you have a number n1, let's take the bullet points, what I have discussed it. If you have a number n1 with any base b, and if I have to convert this into another number n2 to base 10, that is any base to base 10 or to decimal, how we go? We go by expressing as sum of weights. Express this number, express n1 as its sum of weights, it will be converted into a decimal number. And the second part, if I have to convert a number n1 with base 10 into any other base b, so we have seen that there are two parts. There is an integer part and there can be a fractional part. So I am taking integer part as I represent this integer part by I. The integer part. This is the integer part and this integer, and the fractional part and this fractional part. If you have to convert any number into base 10, express this number as a sum of its weights. And if you have to convert a decimal number into any other base, so what you do, you simply, for integer part, it is done by, I can say, continuous or successive division by this base b only. And if you have, and for the fractional part, you go for successive multiplication by this base b to which is to be this number is to be converted. So I hope this is clear to you, how to convert any base into decimal or how to convert any decimal number into any other base b. So now let's come to next article. I'll take another article. That suppose, now I take another type of conversion, that suppose you have a number n1 with base b1, and I want to convert this to some another number n2 with base b2, and the condition is that to b2 such that b1 and b2 both are not equal to 10. None of the bases are 10. If I have to convert this into base 10, I know how to convert this. Or from here to base 10, I know how to convert this. Okay, suppose I say how to convert this number. So what is the procedure? The procedure is that you convert this n1 of base b1 into a number n base 10, and then the number which is converted to base 10, you convert this to another number what you are interested in, to n2 with base b2. This is the process that we follow simply. That is, if you have to convert a number with base b1 to b2 where neither b1 nor b2 are decimal numbers, you go via base 10. The point is that you go via base 10. Let's take an example. I take an example here. For example, suppose I say that you have a number 756. Suppose I say it's an octal number, base 8. And I say that convert this, what is the corresponding number in base 7. Suppose I define another number system that you have base 7, where you have digits from 0 to 6. So I have to convert this. So what I do, first of all, I convert this into base 10, the 756 base 8 into base 10, and whatever I obtain, I convert that number base 10 into base 7. So first step 1. I'll say this is step 1. What I do, I convert the 756 base 8. So since I have to convert the 756 base 8, I am interested that how much is this in base 10 and how to convert any base b into base 10 is by expressing it as sum of its weights. So I'll express this as sum of its weights. Let's put the weight on this. Naturally, the weight on this is 8 to the power 0, weight here is 8 to the power 1, and the weight here is 8 to the power 2. So this one will be 7 into 8 to the power 2 plus 5 into 8 power 1 plus 6 into 8 power 0. This is the corresponding number in base 10, and if I solve this results in 494 as per my calculation. I request you to please cross check it always after the lecture. So this is base 10, means I have reached up to this stage. I have converted this number with base B1 to base 10, and now I'll convert this base 10 into base 7. So my second step 2 is what I have to do. I have to convert this number 494 with base 10 into base 7. It has only integer part. Purposely I have not taken, intentionally I have not taken the fractional part also, just to save the time. All I have to do is to give you the concept only. So it is 494. Integer part means by successive division or continuous division, I can say. I'll divide this by 7. So it is 7 7 ja 49, 0, and remainder will be 4. Further, I divide this 70 by 7 because 70 is more than 7. So 7 10 ja 70, remainder is 0. Further, this 10 is greater than 7. I'll have to divide it again. So 7 1 ja 7, and remainder is 3. Now this 1 is less than 7. I'll stop it here, and from here I write this in the reverse order. So this number, or I can say this number which is corresponding decimal of this particular number, the equivalent base 7 number will be 1304. So my final answer is 1304 in base 7, or I can say that this number 756 in base 8 is equal to this much in base 7, and this is my final answer here. This is the final answer. Now the homework for you, you just cross check it. That is, I am giving another problem here for you. I say that what is 1304 in base 7 is equal to how much in base 8? What is the value of x in base 8? It should be the same result. Alright, it means if you are getting the same result, means these calculations are correct. So this is how you convert. Now let's come to another type of conversion that we'll discuss here. So far we have done these conversions with respect to base 10 and any other base. Now I have told you that the different types of number system that you have. We have discussed various types of number systems, and the number systems that we have discussed is, of course, one was decimal in the very first lecture. Decimal, then binary, octal, and hexadecimal number. Hexadecimal number. Of course, decimal we know how to convert decimal into binary or binary to decimal. This binary has base 2. This binary has base 2, and the numbers, as I told you, this is 0 and 1 digits which are available. Octal has base 8 and hexadecimal has base 16. Now if you see the base of this number, this 2, the base of this number is in the form of, I can say it is 2 to the power 1. This base is 2 to the power 1. On the other hand, this octal, I can say this is 2 to the power 3, and this hexadecimal has a base of 2 to the power 4. Now how to convert these numbers apart from decimal? Suppose I have to go for conversion between binary to octal, or I say binary to hexadecimal, or vice versa of this. Or if I have to go for a conversion from octal to hexadecimal, If I need a conversion from octal to hexadecimal or hexadecimal to octal or any other combination among these three, and these three bases, if you see, they are in terms of powers of 2. So in spite of going via 10, see, if I have to convert octal to any of these conversion from binary to octal or octal to hexadecimal, this is the case where you are converting from one base to another base and none of the bases are 10. So one way is to go via base 10, but here we'll not go via base 10, we'll go via base 2. How to proceed with this, I'll continue in the next lecture. So thanks for the time being.